So, in the next part, we are asked, we are given with a figure. Figure 5.1 shows the molecule of a gas is the volume of gas is half. So, in first portion of the figure, you can see that molecules are in a box with a larger size, and in the second portion, the size is reduced to half. The equation suggests that volume of a gas half the pressure is doubled. Using ideas about molecule, explain why this happens. So, so, as we know that P equals to F over A. Area and pressure has inverse relation. So decreasing volume means that we are decreasing area, and when area is decreased, pressure will increase as they have inverse relation. So I will write the effective area for gas molecules decreases, which means volume is decreased. So pressure will increase is it has inverse relation. It has inverse relation with volume and area. Volume and area. We can also write this expression of the pressure that is equal to force over area. So, question number 6. Question number 6. A dentist uses a plane mirror to see the back of a tooth. A plane mirror produces an image of an object. We are asked to describe the position of the image. So, we know that the image formed on the plane mirror is always behind the mirror. The image of the tooth will appear behind the mirror at the same distance as the object or tooth is in front of the mirror. B part shows that a plane mirror used by a dentist to see a point label X on the tooth. This is the diagram. This is the mirror. This is the eye of the dentist, and he want to see this X point on the mirror. What we are asked, mark the position of the image of X found by the mirror. Draw a ray of light from X to show how the dentist can see the tooth. So, by drawing the light ray diagram, we can also tell us the position of the image form. So, first we will try to form the light rays falling from the tooth on the mirror. Uh, it will tell us the position, and as well as we will also get the ray diagram. So, let's draw it. Let's suppose this is the tooth. A ray is coming from the tooth and falling on the mirror. I will call it I. It is the ray I, incident ray. It falls on the eye of the dentist. Here I will draw a normal. This is theta r, angle made by refracted ray. This is theta I, image made by incident ray. We will extend this ray and a straight line will be drawn from the X. The point where both rays meet will be marked as X. This is the position of the image of X. Image of point X. Here we will form the image, and it is the whole ray diagram. So I will also, and one more thing, it will be extended like this. This is making 90 degree. We can call it as the eye distance of object. This one. Let me erase it. This is the distance I. DI. Distance of image, and this is this is distance of image. Oh, okay, fine. And this is distance of object. This one is the DO. Let me explain it again. This is the distance of the image. This will be marked as DI, and this is the distance of object from the mirror. So this will be marked, or this one you can say that this is the DO. So both of the parts are covered just by drawing a ray diagram. A ray diagram is also telling us the position of the object of the image formed, and also whole rays, incident ray, refracted ray, theta I, theta r is uh, elaborated clearly. So in the next part, we are asked to state one characteristic of the image formed by the plane mirror other than its position. So we know that the image formed by a plane mirror, the size of the image formed by the plane mirror is equal to the size of object. So we can write it, size of image is equal to size of object. Size of object. And another property is the the image formed will be virtual and inverted. Now, in the next part, we are asked to state one characteristic of the image formed by the plane mirror other than its position. So, we know that the size of image formed by plane mirror is equal to size of object. Other, we also can write other characteristics such as that the image formed by the plane mirror is virtual and inverted. So this is the whole question regarding to geometrical optics. It comprises of 6 marks. So just by stating the position, making a red diagram, and stating characteristic of the image, you will get 6 marks. Now, two isotopes of carbon 12 and carbon 14. One of these isotopes, carbon 14, goes under radioactive decay. Describe what is meant by radioactive decay. So you can define the radioactive decay as the spontaneous emission of radiation that can be alpha, beta, or gamma, alpha, beta, or gamma from the nucleus of radioactive element is called radioactive decay. Now, in part B, carbon 12 has a proton number that is also atomic number and 6 and a nucleon number mass number of 12. Complete the table 7.1 for a neutral atom of each of these two isotopes. So we know that the mass number is 12 and we have 6 proton, which is the atomic number. So we know that number of proton and number of electron are always equal, and nucleon number is 12 minus 6 equals to 6. Mass number minus number of proton. So the number of neutron in carbon 12 is also 6. Now number of proton, we know that in isotopes are the elements of an atom having same atomic number but different mass number. So if the atomic number is 12, it means that atomic number is 6, it means that number of proton and electron both are 6, as it is the isotope of carbon. So again we will subtract nucleon number, subtract 14 minus 6, that will give us 8. So which is the number of neutron. Now you can see by adding number of proton and number of neutron we can get nucleon number. Nucleon number. So I can write it as nucleon NO equals to number of proton plus neutron. Number of electron is always same as number of proton. Carbon 12 and carbon 14. So here it means that it has atomic mass of 14. So we will subtract 6 from 14, that will give us 8. Now the other part, a sample of carbon 14 is contained in thin aluminum container of thickness 0.2 millimeter. Radiation from the sample is detected outside the container. When the thickness of aluminum is increased to 6 mm, no radiation from the sample is detected outside the container. State the type of radiation which is stopped by increasing the thickness of aluminum. So we know that alpha is large particle. We can say that alpha radiation is basically helium nuclei, but the sample is placed in aluminum container of thickness of 0.2 millimeter, and still we had detected radiation outside the container. But when the aluminum thickness is increased to 6 millimeter, no radiation from the sample were detected outside the container, which means that it was emitted beta radiation. In simple words, explain how you know that the sample does not emit one type of radiation. So it is quite obvious that it was not emitting gamma radiation, because to stop gamma radiation we need lead, a slab of lead, we may say. So here we have just aluminum container, and we have stopped all the radiations like alpha and beta, which clearly means that the sample was not emitting gamma radiation. If it was emitting gamma radiation, it would not be stopped, or we were not able to stop it with the uh, aluminium container. So by increasing the thickness of aluminium container to 6 mm, all the radiations were stopped, which means the sample was emitting alpha and beta radiations. If it was emitting gamma radiations, then it was not possible, not possible to stop all the radiations, or not all the radiation, to stop the gamma radiation, to stop them using aluminium container. Now section B. Answer two questions from this section. Answer in the given space provided. We are having 8, 9 and 10 means we are given with three questions. Uh, you have one choice in this section, but I will be solving all of them for your convenience. Each I can say that it's a question for extended answers, detailed answers, long question I may say. Question number 8 is figure 8.1 shows a lamp of a car. It contains two metal filaments. Have a look on the figure in part A. Complete the boxes to describe the transfer of energy that take place when the lamp is switched on. So when the lamp is switched on, it is quite obvious that electrical energy is given to the lamp, and to which other forms they are transferred. So it is light energy, and heat is also produced while it is turned on. Part 2. The efficiency of metal bulb is less than 10%. State what is meant by efficiency. How can we define efficiency? Efficiency of a system is defined as the ratio of input energy to the ratio of output energy. Uh, but here we are given that the efficiency of the metal lamp, the metal filament lamp is 10%. So we will be calculating it in percentage. So I will define it is the ratio in percentage of useful output energy to the total given input energy. Mathematically, I can also write it as I will using this symbol for efficiency. Energy in output by energy in input multiplied by 100% in percentage. Multiply by 100, I will get it in percentage form. Now, the filament mm, are usually connected in parallel to a car battery. A student investigates what happens when the filaments are connected in series rather than in parallel. He uses the same battery for investigation. State whether the current, the voltage across the filament, and the total power produced increases, decreases, or stays same when two filaments are connected in series. Let us make a small diagram. Let's suppose this is the direction of current. The resistance, it is R. Let's say both the resistances are same for our convenience. So here the current is V by R, same will be the current here V by R. It is the voltage source. So total current I equals to V by R plus V by R will be 2V by R. Power equals to VI. So it will this equation for power will become 2v square by r. This is the power in parallel. Now let us make a diagram for the same filament and they are connected in series. This is the direction of current, this is R, this is R, this is V, I, current of direction. So here the total voltage is V by 2 and V by 2. R equals to V, I equals to, the total current will be equals to I equals to V by 2R. Again power in series will become Vi, so Ps equals to V and V by 2R. It will be V square by 2R. Now let us have a look to the power. Power and resistance has inverse relation. So when it is connected in series, the resistance is 2R, so means power will decrease. Resistance is increased, so power will decrease. What will happen to voltage? Voltage, if we have a look, so like first of all let's us go towards the current. Current and resistance is also having inverse relation, so it will also decrease. So when current decreases, voltage also decreases. V equals to IR Ohm's law in simple words. So it both, all of these three quantities, current, voltage and power, will decrease. Now figure part C. Figure 8.2 shows us the current voltage graph for two filaments. So let's suppose this is F1 filament 1, this is filament 2. Remember that voltage for both the filament is 12 volt and the current for filament 2 is 2 ampere and for filament 1 is 0.5. Calculate the total resistance of the two filament when they are connected in parallel. First of all, for filament 1, V equals to 12 volt ampere. For F1 it is again it is 0.5, current is 0.5 ampere, so I equals to 0.5 ampere, R equals to V by I, 12 volt by 0.5, R equals to 24 ohms. For F2, V is 12 volt, current is 2 ampere, R equals to V by I, R equals to 12 by 2, R equals to 6 ohm. I will call it R1, I will call it R2, 6 ohm. So 1 over R equals to 1 over R1, total resistance equals to 1 over R1 plus 1 over R2. It will give us R total equals to R1 R2 by R1 plus R2. So 6 multiplied 24 by 6 plus 24 equals to, it will give us 4.8 ohm. So the total resistance is equal to 4.8 ohm. The other part says the two filaments are made from the same type of material and have same length when uncoiled. They both operate at the same temperature. Suggest why one filament has a resistance that is greater than that of the other. First of all, we know that resistivity equals to, or resistance equals to, rho L by A. So we are given the condition that it have the same length when uncoiled, and resistivity is always constant. The only factor is left, that is left is area. So it is possible that the cross sectional area of both the filament is not the same. The cross sectional area of both filaments is different. The one with smaller area will have more resistance. Figure 8.3 shows a relay used to switch on a car headlamp. This is the whole diagram. This is the switch. This is the iron core and a coil. This whole system is called relay. It is a pivot. This one is the shorter arm and this one is the longer arm. These both are flexible contacts. This is iron armature. So explain why the headlamps H light up when the switch S is closed. Let us discuss the whole scenario. Current will flow in this direction. When the switch is closed. So when current flows in it, it will act as electromagnet and it will create opposite pole on this iron armature. It will result in attraction. It will attract it. Thus, the iron armature will turn around. A movement will be created and it will turn around. This will go downward as it will be attracted towards this. As a result, this will move outside, causing these flexible contacts to meet each other. So when these contacts meet each other, the circuit for the headlamp will be completed and it will light up. So how I will say, when the switch is closed, switch SWID, switch S is closed, current flows through the coil. Current will flow through the coil, flow through the coil, through the coil, and iron core. It will become, or it will act as electromagnet. As a result, it will induce opposite pole contraction will take place, causing shorter arm to rotate around or across across the pivot, and the longer arm will move towards flexible contacts connecting both of them. The circuit will be completed and headlight or headlamp H will turn on. Question number 9. Ultrasound and X-rays are both used for medical imaging. Define what is ultrasound. So basically ultrasounds are sound waves. Ultrasound are sound waves having frequency higher than 20 kilohertz, and that cannot be heard by human ears. Describe what happens to ultrasound waves is they meet the boundary between two different materials. The ultrasound waves are either reflected or refracted. When they meet the boundary between two materials, some of the energy is also absorbed. They may be reflected or refracted as they meet the boundary of two materials. Some of energy is also absorbed by the material, also absorbed by the material. Now, to produce the image of an unborn child, an ultrasound emitter and receiver are placed close together to the mother's skin. Here we are given the diagram shows the pulses detected by the receiver. So it is 0.02 millisecond, and it is This is 0.05 millisecond, means the difference is between both of these points is 0.03 milliseconds. Now let's suppose this is the receiver, this is the emitter, waves goes, this is, let's suppose, unborn child, it is the skin of the mother, this is emitter, these emit rays, it strikes with the unborn child and is refracted and detected by the receiver. So here you can see that the distance equals to 2d. Why it is 2d? One is from the emitter to the baby, the other is from the baby to the receiver. So total distance equals to 2d. Pulse A is the emitted pulse and pulse B is the pulse that is returned. So it is by the emitter and this one is detected by the receiver. Pulse is the first, again pulse A is the emitted pulse and pulse B is the first pulse that returned from the unborn child. The average speed of ultrasound in human tissue is 15 meter per second. Calculate the distance between the emitter and the child. So how we will calculate it? Here d dash equals to v cross t. T equals to 2d, so I will write it 2d equals to 1500 multiplied by 0.03. D equals to 1500 multiplied by 0.03 divided by 2. It will give us 22.5 millimeter or 0.0225 meter. So we may write it as 22.5 mm equals to 0.0225 meter. This is the distance between the emitter and the child. In the other part, we are asked the speed of ultrasound in human tissue is close to the speed of sound in water. Suggest approximate values of speed of sound in gases and in liquids. So the speed of sound in gases is like 300 meter per second. Its range varies from approximately 300 meter per second from 150 to 1000 meter per second, depend upon the type of gas, which gas the sound is traveling. And in solid it is almost 5000 meter per second depending upon the solid material. Its range is from 2000 to 8000 meter per second. In figure 9.2 shows an X-ray of a hand. An X-ray detector is placed just between the hand and an image of the bones and human tissues around the bones is formed on the screen by the detector. What we are asked is to define what happened to X-rays to produce the image. So we can write that X-rays are electromagnetic waves or electromagnetic radiation. X-rays are electromagnetic EM radiations. Which are absorbed by object based on its density. The whole black region shows that there is nothing present, and X-rays directly falls on the photo plate. So the black region shows that there is nothing, and X-rays directly falls on photo plate. The solid white lines are bones which absorbs most of the X-rays. The contours the contours around the solid bones are tissues that absorbs X-rays partially. In the second part, the wavelength of X-rays used is 2 multiply 10 power minus 9 meter. The speed of electromagnetic waves is 3.0 multiply 10 power 8 meter per second. Calculate the frequency. So we know that V equals to F lambda. So what we are asked to find speed, frequency, that shows that frequency equals to V over lambda. V is 3.0 multiplied 10 power 8 meter per second, and lambda wavelength is 2.0 multiplied 10 power minus 9 meter. By calculating these, we will get 1.5 multiplied 10 power 17 hertz. So the frequency is 1.5 multiplied 10 power 17 hertz. In the third part, suggest one reason why X-rays are not used to form an image of unborn child. X-rays are radiation that destroy human cells. X-rays are radiations that destroy human cells. Long exposures can cause cancer. This is dangerous to unborn child. Question number 10. Figure 10.1 shows a motor lifting a mass. Figure 10.2 shows part of the circuit diagram of the connections of the motor. Part A. The current in the motor is 1.5 ampere and the voltage supplied by the battery is 8 volts. So this is the current I, this is the voltage V. Complete the circuit diagram in figure 10.2. To show an ammeter and a voltmeter in the correct position to take these measurements while motor is working. So we know that to get an accurate measurement of voltage, a voltmeter should be connected in parallel with the voltage sources and an ammeter should be connected in series. So this is how we will connect ammeter and voltmeter in series and voltmeter in parallel. The motor takes 4 seconds to lift the mass. Calculate the electrical energy transferred to the motor at this time. So electrical energy equals to power into time and power equals to Vi multiplied by time. V is 8 volt, I is 1.5 ampere and time is 4 seconds. So by multiplying all of these terms we will get 48. Our answer will be in joule as it is energy, so answer is 48 joules. The other part says the motor lifts 150 gram mass to a height of 80 centimeter. In the next part, it is said that the motor lifts 150 grams through a height of 8 centimeter in 4 seconds. Calculate the gravitational potential energy gained by the mass. Gravitational field strength G equals to 10 Newton per kg. So PE potential energy equals to mgh. Mass is 150. We will convert it to kilograms by dividing it. We will get it in kilogram. Multiply by 10 Newton per kg and height is 80 centimeters. So converting it into meter just by dividing it by 100. So by calculating all of these using calculator we will get 1.2 Newton meter equals to 1.2 joules. So I will write it, the gravitational potential energy gained by the mass is 1.2 joules. State two reasons why the gravitational potential energy gained by the mass is less than the electrical energy supplied to the motor. So as you know that efficiencies are not equal to 100% because some of the energy is always lost in other forms. So here some energy is lost in heat of the motor and some energy is converted to kinetic energy of the motor. Some energy is converted to the kinetic energy, that is Ke, of the motor. Question number 10 B part figure 10.3 shows the structure of the motor. When the mass reaches the top of its motion, the switch is opened. This disconnects the battery and causes the mass to fall. The coil turns as the mass falls. As the coil turns, a small voltage is produced. Explain why voltage is produced as coil turns. So we will write it as the rotation of the coil cuts the magnetic field. Field lines causing a change in magnetic field, which induces an EMF, electromotive force, in the coil according to Faraday's law. Thus, voltage is obtained on the terminals. Part 2 of Part B, subpart of Part B, is the mass falls. The student connect the wires between point A and B shown in the figure. He notices that the mass takes longer time to fall when the wire is connected. The student suggests that it is an example of Lenz's law. State Lenz's law and suggest why the mass takes longer to fall. So Lenz's law is simple. Lenz's law states that the induced current flows in the direction that opposes the cause producing it. The induced current flows in the direction that opposes the cause producing it. Now, when wire is wire is connected between A and B, the current starts flowing. The current starts flowing in the coil. The current carrying conductor experience the current carrying conductor experiences a force which is opposite to the cause producing it which is Lange's law. This is just for your sake of information. Here we ask that the student suggests that it is example of Lange's law. So this is the portion which answers this part. Opposes the cause producing it. This force slows down the motion of the mass, and this slows down the motion of mass and it takes longer time to fall. So this was your whole paper. I guess it will be clear to you. Please like and subscribe my YouTube channel for solution of past papers and physics related contents.